Hello guys, my name is Syed Reza. In this video, we're going to see what are branches, networks, rungs, and crossing in the ladder programming language. Before that, I just wanted to inform you about all the great content I have been releasing on the plcgoods YouTube channel, which includes industrial automation PLC programming, HMI and microcontroller-based developments. If you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, if you remember, we wrote the 3 top conditions in this ladder program, and we've seen how branches can be inserted. With branches, we can make parallel logic, in other words or logic. Because the output will be turned on if the power pass from first branch, or another branch. In other side, there is AND logic. It's when ladder component are inserted series, like S3 and S4 contacts or like S2 and S4. Because if S3 and S4 are pressed simultaneously, the power will pass of the branch. Branches are opened downwards after a selected element. And branches are terminated after the selected LAD element. Let's come back to my programs with press Ctrl plus Z key on keyboard. Now let me delete this. As you see, I can close branches manually. And if you want to delete a branch, all element of that branch must be deleted. Now we're going to write appropriate program for another output, the 3-phase motor. As you see, there are 3 conditions which turn the motor on. So let's write its program like the lamp program. Now we just need to write appropriate tags, because we've defined our addresses before. Okay, our program is complete. Let me to have a better view of our program. As you see, there are 2 circuits called rung. A rung starts with a power line, and closed by a coil or a box, which the result of logic operation will be written there. Now these 2 rungs are in a same network with this name. Suppose you want to have a blinker lamp when a 3-phase motor is turned on. In this case both of these outputs can be in a same network. But in our project the lamp and the 3-phase motor are independent. So to have a better program, I move the 2nd rungs to next network. As you see, the name of network 2 is changed to the contactor of the 3-phase motor. If you remember, this is our output comment which has been defined for K1 output. Now see what do these icons do. With these icons, we can choose which information appear in the program. Addresses, tags or comments. Let's see the next concept. Crossings or nodes. This is a crossing, for example. So, a crossing is a node where one branch is closed, and the same time, another branch is opened. In this case, virtual power reach to output if S1 switch is pressed, or S2 or S3, and one of next two switches are pressed. I press Ctrl+Z on keyboard to come back. Now we're going to test this program. If the PLC sim of TIA software has been installed in your computer, you able to test the program without any PLC. To test, click on Online menu, select Simulation and click on Start. For this message, click on OK. This message warns you, starting simulation will disable all other online interfaces. Click on OK. Now you can see your virtual PLC on the left side, which is connected to TIA software. Now TIA software starts to check and compile your program. Then click on Load to move the programs to virtual PLC. This message tell us the loading is complete without any error. Then, here click on Start Module to start PLC. Pay attention, there isn't any hardware switches on the CPU to start it manually, unlike S7 300 or S7 400 models. It's mean, we need TIA software to start the S7 1200 CPUs of Siemens company. Now, the latter program in my computer has been transferred to my virtual PLC, which you see it on the left. I want to see what happen in my virtual PLC program, not in my TIA software. So click on this glasses icon. When I press this icon, TIA software show me the PLC program which connected to TIA. So, the working windows is changed a little. For example, the color of this window is changed to orange color. The instructions in the left side are gone. Instead of that, a CPU appear here. Or on the left, appear some green circle. To turn output on, virtual power should reach to output from one of three branches. For example, consider first line. We want to change the state of normally open contact with I0.0 address to close. To do this and base on this wiring, we should press S1 switch to reach 24 volt DC to PLC input with I0.0 address. But our PLC is virtual. It's not real. So we should change the state of PLC input with another way. Here, in the watch and force table, click on force table. First select any address you want. I select S1 with I0.0 address. And here write a valid value. For a binary address like I0.0, we just have two valid value. 0 or 1, in other word false or true. I write 1 here. Then, click on this icon, to use inserted value in program, instead of real value. As you see, the main LED color is changed to orange. Because this way usually is used in maintenance processes. When an address get a value from force table, the F letter will be appear. In our latter program, power is reached to output, from first line, and the output is turned on. But here, the virtual power just passed the first contact and hasn't reached to this output. So, let me again, to change the state value of I0.3 address, which its tag is S4, in the force table. Now both output are turned on. With force table you can change any address value. To cancel force values, come back to this table and click on this icon. As you see, the main LED is turned off. And in the program, our addresses have their real value. After testing, click on glasses icon, to exit of CPU. Also, we can compile, or download programs to PLC manually. Click here to compile your programs. Its result shown here. Now select your PLC and click on this icon to download PLC programs and its settings, to a virtual or real PLC. Pay attention, always the result of your actions are shown here. Similarly, let me test this program with my PLC. So, I have to close the virtual PLC, otherwise, TIA software won't find its connected PLC. Again, TIA software needs to search its connected IP address. It finds my S7-1200 CPU. Let's load the program. This message says, my PLC has an incompatible firmware version. To solve this problem, let's go to device configuration. Now, for the selected PLC, I change its version. Also, let me insert my analog module. Again, I select the PLC, to load the program and hardware settings. As you see, the error has been solved. Click on Load. I select Start Module and then click on Finish. Now, let's open the main block, and activate program monitoring. I can turn on or off the output with these connected switches. Let's compare the PLC program with the EKTS circuit. Now, the S3 and S4 switches are pressed, and the lamp and motor are on, in the EKTS circuit. Similarly, this state is true for the PLC program. Let's turn off the S4 switch in both of them. In this state, based on EKTS circuit and also the PLC program logic, only the motor will be on. As you've seen, the ladder language is similar to industrial circuit. It starts from a power line and based on some condition, turn on some outputs. A crossing is a node, which one branch is closed, and the same time another branch is opened. Series or AND logic can be created by inserting ladder component in a same line. We can have parallel logic, in other words or logic by using branches. And we saw, what is rungs, and how arrangement them in networks. In this project we've used just these instructions. These instructions are used frequently in ladder language, and you can find them in this folder. Here are other instructions which can be used in ladder language, which oriented in this window. In next lessons, we'll learn them. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.